Section 6.3, special right triangles. So we're going to talk about a couple of triangles that have some special properties, and hopefully you'll learn a few rules about those that kind of fit in with those. So let's take a look here. First one we're going to talk about is called a 30, 60, 90 triangle. So 30, 60, 90. And these have a very special relationship between some of the sides. So let's take a look at this triangle over here. And what you will see is our 30, 60, 90 triangle. And just a couple things to point out. Notice that the 30-degree angle here is opposite the small side, which we're going to call A. The 60-degree angle is opposite B. And C, of course, is always opposite the right angle. So if we look at this, the special relationship in a 30, 60, 90 triangle is that the hypotenuse C is twice as big as A. So, you know, we talked about the Pythagorean theorem, and recall Pythagorean theorem was C squared equals A squared plus B squared. We're going to have to use that again, so be aware of that. But here we know something before we even get into all that. If we know we have a special 30, 60, 90 triangle, we know that this side, the hypotenuse, will be twice as big as the smallest side. A is going to stand for the smallest side, or the one opposite the 30-degree angle in this particular example. All right, so let's take a look. Here's our triangle. We know that our hypotenuse is 10 feet, and we want to figure out A. Well, all right, we know, we just said just a little bit ago, that my hypotenuse C was going to be equal to 2 times A. That's an A, by the way. 2 times A. And so if we know that the hypotenuse is 10 feet, 10 equals 2A, we should be able to figure out that A equals 5. So my hypotenuse is 10, my short side is 5. Now we still don't know this side, so we would have to go back to the Pythagorean theorem to figure that out. But now we know C is 10, so we can say 10 squared. We know A is 5, so we can say A squared, that's 5 squared, plus B squared. And now we simply need to solve for B. So let's kind of get rid of some of these squares. Let's say that, so we can rewrite this. I'm going to go over here to the left here. So we can say 10 squared is 100. 100 equals 25 plus B squared. And let's subtract 25 from both sides. And we get 75 equals B squared. To find B, we must take the square root of both sides. So B is equal to the square root of 75, which you would do on a calculator. And when you punch that into the calculator, you find out that that comes out to be about 8.7. So it's 8.7, you know, kind of round it off to the nearest 10. Okay, so 8.7 is my approximate answer for that particular side. Now we know the exact answer for A is 5 and so on. But that's just a simple thing we can do when we have a 30, 60, 90 triangle. All right, so it's now your turn. I would like you to do these problems right here. Find the missing length or lengths and round to the nearest tenth if necessary. Go ahead and do that. All right, so you're back here. Hopefully you have all that figured out. Let's take a look at the first one. Here's my hypotenuse 12, so we should know that this one is automatically 6. And to solve for that, we're going to get 12 squared equals 6 squared plus B squared, to solve for B here. 144 equals 36 plus B squared. And if we subtract that out, what do we get? 108 equals B squared. Take the square root of both sides. And if you punch 108 into the calculator, you get about 10.4, rounded off to the nearest tenth. Okay, so that is A. Okay, let's do B. All right, so here we go. We got 15 there, so we know that this is going to be 7.5, and now we've got our one last side to figure out. So 15 squared equals 7.5 squared plus B squared. We do the same things that we've been doing here. Okay, so 15 squared is 225. 7.5 squared, 56.25 plus B squared. And if I subtract 56.25 from both sides, we get 168.75 equal to B squared. Take the square root of both things, and B equals 12.99, so probably 13 is what I rounded off to. 13 for B. Okay, and let's take a look at the last example here on C. C, they didn't give us the hypotenuse, they gave us A. Well, we know that the hypotenuse is 2 times A, so we know that this automatically is 14. And then once again, we've got to solve for B. So we're going to say 14 squared equals 7 squared plus B squared. And 14 times 14 is 196. That equals 49 plus B squared. So 147, if I subtract 49 from both sides, take the square root of 147, and I get 12.1. So 12.1 is what B is on that one. All right, so those are those three. All right, the last triangle that we want to talk about of the special ones is a 45, 45, 90 triangle. In a 45, 45, 90 triangle, what you'll find out is, first of all, since there are two angles that are the same, the sides opposite those angles have to be the same. So what we know in a 45, 45, 90 triangle is A and B are the same length. Okay, so we know that that's going to happen no matter what because of those angles. So this is another special one. So in this case, let's say that we only know one side. So let's say we find out that B is 15. Well, we automatically know if B equals 15, that A is 15. And then if we want to solve for C, it's simply C squared equals 15 squared plus 15 squared. So that's 225 plus 225, 450. That's C squared. And then we need the square root of both sides. And when we take square root of 450, we get about 21.2 for my answer. It talks about there are always extra examples if you go to that website. So, you know, this section, these couple of sections might be a little tougher than stuff we did in the last chapter. And if that's the case, go ahead and take a look at a few more examples there that you can take a look at.